So what we're going to do again is we're going to take on the left side here 3 orthographic views, and we're going to turn those into one isometric object, one 3-dimensional solid. So I'm going to step you through this one step at a time. I highly recommend that you heed my advice for the order in which I go about drawing this. It really does help to go in a specific order. So let me discuss what I'm saying here. So first, I'm going to use a lot of color codes for this to help. So the first thing I see is this, and you don't have to draw what I'm showing you in the beginning. The reason we have these grid lines is to show depth. That's the reason we have these grid lines. They're not like normal XY grid lines, right? These are orthographic or isometric grid lines. So we want to recognize that to show depth, this is what it would look like. And this is not my solid. I'm just giving you a quick sketch. But this is how we show depth. And to show height, we would move up the grid lines. Okay, so if I were making a solid, this is not what I'm drawing. I'm going to change it. I'm going to erase it in about 30 seconds. Okay, I can physically see, and bear with me here. Make believe that's there. Okay, we can physically see what a solid would look like on an isometric grid. That's why we're using these grid lines that are at odd angles like this. That is absolutely not the solid, right? Can we all see that that is not the same? So I'm going to erase that, and we're going to go through together how to actually get the solid itself that we're seeing here. You know what? Let me just undo. Sorry. Okay, perfect. So I'm going to start with red, and here's what I'm going to do. I'm going to highlight on my orthographic view first. I'm going to highlight that in red. And I recommend you do this for the first one. I know it might seem tedious. Some of you are like, I know how to do this already. But it will help you when it comes to drawing the other ones that are a little bit tougher. That red line needs to appear somewhere on my grid. So when I think about this, if you recall when we were doing this, when we had a solid, we turned our head and we drew the top view like this. So the top view that I'm seeing here should translate over here and be tilted like this. So again, this top view should look like this, tilted to the side. So when I do that, I'm going to start here. Oops. I'm going to start here, and I'm going to go back a certain distance. Now, how far should I draw that red line? Do I have any dimensions? Obviously not, right? So for a diagram like this, where dimensions are not given, I would recommend that you label dimensions that make sense. That add up to the right values. So, what length should we call this red line? Give me a number, and make it reasonable for the amount of boxes we're going to have space for, right? What are you thinking? I'll go with 5. That sounds good. That sounds good, Carlos, right? Yes. Carlos, 5. Good, Carlos. It's 5 sounds right for me. So if that's 5, again, if that's 5, these lengths here, what are they going to be? And give me an approximation of what makes sense here. What makes sense? Altea, what are you thinking for this line here? 3. I would agree with Altea. Why isn't it 2.5? Yeah, we could clearly see that this length is unequal to this length. So we absolutely can't make them both 2.5 and just say, oh, split it down the middle, right? Half of 5. So instead, Altea recognized that this length on the right side, I'm going to use blue for it, is a bit longer than this one here, which is in green, and that's a 2 right there. But they add up to 5. So the numbers make sense. They're logical. Next, how about that bottom portion of the top view, right here? What's a good estimation for this and for this? What are you thinking for these two? Because we're going to need here, right? And then we're going to need here. And then the sum of these two will equal what the top dimension is. So what's reasonable scale-wise compared to what we have? Like, does it make sense to call this 3? Obviously not, right? Because this is already 3. Is this 2? Maybe, but it looks a little bit smaller probably, right? I would agree. 1.5, Mark? You can say 1.5? I think it's reasonable, right? And this one is probably the same. It might be slightly different, but for the sake of this, I'd say let's call these both 1.5. Just so that our numbers make them a little bit simpler to look at after. So this top unit makes that 3 then, if each are 1.5. So that's how I start my diagram, by labeling stuff. And I'm going to leave those 1.5s as black. Okay, I'm going to use black for that color. So did I make the red one correct? Let's see. 1, 2, 3, 4, 5 boxes. And how do I count isometric boxes? I count them diagonally. Take a look. This is 1 box, 2 boxes, 3 boxes, etc., etc. So every time I get to another isometric line, I've counted 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes deep. So my red line that I drew works. My red line works. What do you think I should do next? What do you think I should do next? Should I go to the green line next? Probably not, right? Because it's not connected to the red line. What do you think, neighbor? Yeah, either that yellow-orange line or the black line on the bottom. One of those two, right? I agree that the yellow-orange line looks like the best one to go to next. So I'm going to do that. Now, here's what's interesting about isometric lines. The angle on the isometric grid is not going to look like the same angle you have here. What angle do we have between the red and the yellow line? Everybody, what angle is that? Right angle, or 90 degrees, right? But it's not going to show up necessarily that way. But what I notice is that my grid lines are made in such a way that the intersection of 2 diagonal isometric lines is always 90 degrees. That's the whole rationale behind isometric lines. That these angles are going to always be 90 degrees. And again, if I do it here, right, this, that's 90 degrees. If I go here, and then I cut over right here, that's 90 degrees. So any intersection of 2 oblique, any of these 2 angled isometric lines, any intersection is going to be at a 90 degree angle. Okay, it's always going to be at a 90 degree angle. So far, so good. What's next? What's next from here? Carlos?
The 2.
The 2. What color?
Green.
Green. Anybody colorblind? So I know. Honest question. Anybody? So we're going to go 2 from green. So let's come back 2 now. Let's come back 2 units. And I know I've come back 2 units. And look, the green line. On my top view, what is the green line parallel to? What is the green line parallel to in my top view, Kai?
The red line?
Yeah, the red and what else?
Blue line.
And the blue line. So the green and the red need to be parallel. Look at my diagram. One of them is on a slanted upward right line, and the other is on a slanted upward right line. These are parallel. The green and the red are parallel in my isometric view as well. Very good. Next. Mary? Yeah, and the 1.5 is going to get slightly tricky because we have to go a half a unit, right? So I'm going to zoom in a little bit. I'm going to zoom in for this one. And I'm going to go back, not just 1 unit, 1.5 units. Does everybody see that? I recommend that you zoom in to see it a little bit better if it helps. But I'm going back 1.5 units. Okay. After that, Elizabeth? Good. The blue line, that's 3. And what line is that parallel to again, Elizabeth? The red line. So that means that I'm going to start the blue line here, and I'm not going to draw it straight down. I'm not going to draw it at an angle. I'm going to draw it equidistant between my isometric lines. It's going to follow along this midline right here. And this is a tougher one to draw because you're not actually following one of your iso lines here. So let's go ahead and take a look at this. And this is 3, right? So I'm going to go 1, 2, 3. So again, the blue line should be parallel to the red and green line. Very good so far, very good. And the last part for the top view, Mr. Salami.
The black line.
The black line, and where is that going to connect?
From the red line to the blue line.
Correct. Oops, I used the black line we said. All right, awesome. So are we done? Do we have a solid?
No.
Not yet, right? We can see the solid forming, but we don't yet have an actual solid. Okay, let's move on to the front view, please. The front view. If 1.5 is the width of this box, what might you call the height of this box? Probably 1.5 also, right? They're pretty darn close to the point where we could practically say that this is the same as this, the same as this. It's not, we can see that these are slightly different, right? Does everybody see that? They're slightly different. But for the sake of this, we're going to call these the same right now because we labeled 1.5 up here. So although it is slightly shorter than this one, we're going to label both of these 1.5. So let's start labeling everything. That's 1.5 by 1.5. That's 1.5 by 1.5. Where's that? This here, right? Yeah, but because the diagram above it we labeled as 1.5, it has to be the same. And the same thing up here, Altair? We have to go straight down. Remember that? So whenever you're looking at the top view or the front view, we have to consider the fact that these have to line up. So because this is 1.5, so will this be. And because this is 1.5, so will this be 1.5. The only reason I'm making this 1.5 here is because it's approximately the same as this right here. So I'm calling the height of my solid 1.5 as a result. And I'm calling the height of my solid 1.5. So how am I going to do this then? The front view tells me that I should see 1.5 by 1.5. But I don't see that. How am I going to do it? Anybody have any idea? Anybody see it? Yeah, Ron.
You go down in the red line, 1.5.
Good.
And you go horizontal.
And that, horizontal.
Well, like, actually go on the other side where the blue is, and then you go 1.5 down.
And then?
Connect that.
And then connect those two. So Bronwyn sees it visually. So if you're into art, if you visually can see stuff, it helps a little bit. If you're having trouble, just watch what I'm pointing to. So 1.5 down, 1.5 down, that would represent this height and this height right here. And then connecting those two. So let's show that here. Again, I'm going to drop this down 1.5 units. I'm going to drop down from here 1.5 units. I'll use black for now. So those are the two 1.5 heights on the side from the, the side of the front view, but on the sides of that rectangle. So this here, I'll highlight it. This here is right here. This one right here is right here. Now, if I looked at the front view only, imagine I didn't have the top view, right? And I only looked at the front view. I would be looking at the front view and being like, oh, you know what? This is clearly flush with this, right? These are the same exact plane. But in reality, this right here is all the way back over here. Okay? So all the way back there, it's dropped back because this is empty space right here. So this has to be empty space in this region, so that other face is going to occur over here. Let's finish off this one though. Let's connect the last two parts of that those black lines. And we've got that front one. So that's this right here. Okay? Go ahead and practice for about 20 seconds. Try to draw this one. Where would this one end up, and what would it look like? So forget the side view again. Don't start with the side view. Go right to the front view. We did the left part of the front view. Now do the right part of the front view on your diagram. I'm going to give you a little bit just to practice it. And then I'll put the answer up, the drawing up. If you need help, I'll give you some pointers here. Think about the fact that this comes straight down. It's coming straight down from here. This comes straight down. It's coming straight down from over here. We want to see that this region is empty space from above, so this region needs to be an empty space from above. Check yours with mine. Check yours with mine. So again, these are identical, aren't they? 1.5 by 1.5. 1.5 by 1.5. They're the exact same shape. And those planes are parallel to each other, right? It's like having this piece of newspaper, right? One of them is here, that's this one, and one of them is back here. Do we all see what I'm pointing to right here? The planes are parallel. If they weren't parallel, they'd look like this. They'd be at an angle. But these planes are actually parallel to each other. So in black, we've got the same image there. How do we now move into the side view? The side view. What should my numbers be also? That's the other question, right? What are these lengths and stuff? Give me some information. Go ahead.
The long one's 2 on the
So-
horizontal.
Yeah, that's 3. And what about the other one?
The other one's 2.
So Altea can see it clearly right away, right? She's got the answer, 3 and 2. Very good. but we want to visualize if we're having trouble with this. So 3. Why is she saying 3? Why is she saying 3 there?
It's the same as the
Yeah, the 3 on the bottom here, take a look. This 3 is the same as the top of it, and the top of it is actually this blue line right here. So from the side view, we would see this, and that's right here. That's what we're seeing. So let's just finish this off and connect right here. Let's connect these two spots so we can see this 3 by 1.5 rectangle. So again, in case we're struggling, I'll point it out on here. We've got this face right here is this guy right here. This is 3 because this is the same as it, and this right here on the top is really this length of 3 right here. So these are parallel to each other and the same length. Again, these are parallel and they're the same length. So we're almost done. We're pretty much there. We've got to finish off one part still. What's the last part? What's the last part? What do we got there, bro? Good. And then? And what would this length be, brother? 2. And that comes from? Right there, the 2. So let's label our diagram if it helps. This 2 is really representative of going back 2 units. And then we have to go up 1.5 still here. And that's this 1.5 right here. So let's go back 2 units. It's okay. And then let's connect straight up. And again, this last rectangle, 2 by 1.5, is this. 2 units back, 1.5 units in height. So it seems at first like this could be daunting and difficult if you have trouble visualizing it. And it may be a little bit difficult. And you may have to struggle through the work. And that's okay. It really is okay. But if you're sitting and you're not trying, you're not sketching, you're not going to get anywhere. So for the rest of the next, say, 20 minutes or so before I give you homework, the homework packet, I'd like you to practice the next 2 with the person next to you. And if you want to, you can move around and switch and go with somebody else, but with another person in general is what I want to see. So I've got like 2 here, 2 there. Klein, you should slide up. You and I'll take and work together right here. Ladies, you're here. 2, 2, 2. We have 2s, and you guys have to be a 3 in the back. Okay? So try to check with each other. Use color coding systems to help you, please.